All right. We are going to have our first review for our year final. Okay, so we are actually going to be going over, excuse me, half of the things that we learned this year already. All right, so the first thing, if you remember all the way back to the beginning of the year, was our exponent rules. Okay, so when we are simplifying exponent rules, okay, let's go ahead and write our exponent rules up here. Okay, we had a few rules that we learned about. The first one was our product rule. Okay, this is where we add the exponents. Okay, then we had our quotient rule, where we subtracted or canceled the exponents. Then we had our zero rule, okay, saying anything to the zero power is equal to 1. Okay, then we had our negative exponent rule, and thinking it switched places, okay, either from the top to the bottom or from the bottom to the top. And then we had our power to power rule, and that is where we multiplied the exponents. Okay, so that's just a little quick recap of the exponent rules that we learned about this year. Okay, so let's go ahead and look at number 1. We'll zoom in a little bit. Okay, so the very first thing that I notice in number 1 are these parentheses around this whole expression, and the whole thing is being brought to the negative second power. Okay, now here's the great thing about exponent rules. It doesn't matter what order you actually simplify this in. Okay, whatever you see first, you can simplify. Okay, the first thing that I see is this parentheses, and it's all being taken to the negative second power. Okay, well, whenever I see parentheses, that's our power to power rule, which means we're multiplying, okay? Which means we're taking this -2, and it has to multiply to every single exponent inside, everything with a base, including the -2, which is technically to the first power. Okay, so when I take this -2 and multiply it to all these exponents, including that invisible 1, it becomes the base, so -2 to the power of 1 times -2, so -2 to the power of -2. X to the -2 times -2 is +4. Y to the power of -5 times -2 is +10. And then y to the power of 3 times -2 is -6. Beautiful. Okay, the second thing that I notice, and it usually jumps out pretty quickly, are these negative exponents. Remember that in your answer, your answer should contain only positive exponents. So if you have negative exponents, you know you're not done. Okay, so remember the negative exponent grabs, in fact, I missed something. Wow. This is technically a -1 to the first power. Okay, so that would actually be, I'm going to just get rid of that negative sign, -1 to the power of -2 as well. I'm glad I caught that. Okay, so remember, the -2, that negative in front of the 2 is technically a -1. Okay, that's why it also had its own little invisible 1. That was tricky. Okay, but anyway, so I still have these negative exponents. Remember, the negative exponent grabs its base, okay, and moves it to the bottom. Okay, so, and in fact, I believe, yeah, okay, so we'll just do that. So when it moves it to the bottom, we have x to the 4th and y to the 10th left on top. Okay, I'm just thinking through this little negative sign. It's still giving me an issue. Okay, so that would be -1 to the first power. Yeah, okay, so we're good. Okay, and then since it grabbed all its bases and moved to the bottom, it's now -1 squared to the positive 2 times 2 to the positive 2 and y to the positive 6. All right, so now we can do some simplifying. Okay, so first of all, I have -1 squared, which is -1 times -1, which is just going to turn into a 1. Okay, and since that just turns into a positive 1, it doesn't change anything, so I'm just going to go ahead and get rid of it. Okay, remember 1 times anything is just itself, so it technically becomes invisible. Okay, so now the only thing that I need to simplify is this 2 squared, which is going to turn into 4, 2 times 2, which is 4. So we have 4 on our denominator. Okay, x can't be combined with anything, so that stays x to the 4th. But then I have 10 y's on top and 6 on bottom. Okay, so think 6 of them will cancel out from each, leaving 4 left on top. Okay, so we have no more y's because all 6 of them canceled, but y to the 4 is left on top. And there is our simplified expression using exponent rules. Okay, let's do number 2. So the first thing, again, that I notice are these parentheses. Okay, so I have 4 that's going to multiply to every exponent, including that 2 to the positive 1. So these guys stay the same, so this is -m, -1, n to the 5th, times 2 to the 1st times 4 is 2 to the 4th. M to the 0 times 4 is m to the 0. N to the 0 times 4 is also n to the 0. All right. One thing that always jumps out at me are the zeros. Okay, remember 0 rule is anything to the 0 power is just 1. And when you're multiplying by a 1, it doesn't change anything. So those guys technically just cancel out. Okay, so we're left with this -m to the -1, n to the 5th, and 2 to the 4th. Okay, well again, I see that I have this -1. It's going to grab its base, which remember is just the m. It's not the -m. That's technically a -1. Okay, so what we have left is -1 was left on top, times n to the 5th, times 2 to the 4th. Okay, and then we move that -m, so it becomes m to the positive 1, or just m. Okay, then the only simplifying I can do here is 2 to the 4th. I can just take that to a number. So we can use our calculator and find out what 2 to the 4th is. 2 to the 4th is 16. Okay, so that turns into 16. 16 I can then multiply with the -1. So this becomes -16. And I have my n to the 5th on top over m on bottom. And there's no more simplifying that I can do. So that is our simplified expression. Awesome. Alrighty, a big thing we talked about this year is solving equations, okay? Trying to get the variable by itself, figuring out what number does that variable represent. And remember, the variable is just the letter in the alphabet. Okay, so it's a multi-step equation, which means we're going to have to do numerous things to get this b by itself. Okay, so the first thing I see are parentheses. Whenever you see parentheses, you usually want to get rid of those first. Okay, so I'm going to go ahead and distribute. Okay, that means we're going to multiply. So this becomes -5 times 7b is -35b. -5 times +1 is -5. And then we just have that +2 that's left over, and it still equals -39 plus b on the other side. Okay, so we got rid of those parentheses. Now we can either start moving things, combining things, but one thing I see is that I have b's on both sides of my equal sign. Okay, we cannot solve for b if they're on both sides. So we need to either move one of them to the other side. I like moving the smaller one. Okay, so remember the smaller one out of 1 and negative 35 is negative 35. So I'm going to do the opposite. Add 35b. Add 35b. Okay, so this is negative 39. 1 plus 35b is 36b. And it equals, well, what is negative 5 plus 2? That is negative 3. Okay, so we can see that our equation is slowly getting smaller. Okay, so I'm looking at my side with my b now, because I'm trying to get this b by itself. So I either need to get rid of this negative 39 or times by 36. Okay, remember, get rid of what's farthest away first, so we have to get rid of negative 39. Do the opposite by adding 39 to both sides. So I'm left with 36b equals negative 3 plus 39 is 36. Okay, I'm going to just rewrite it over here so we have more room. So I have 36b equals 36. Okay, I'm still looking at my side with my b. Well, this is saying 36 times b. So how do I get rid of times by 36? We divide by 36. So I get b is equal to 36 divided by 36 is 1. And that's our answer. When we're solving equations, we're just trying to figure out what number does that variable represent. Okay, let's do it again in number 4. So again, first thing I see are some parentheses, which means I need to distribute what's ever in front. This is a negative 1 that's in front, so I'm going to multiply it to everything inside. Negative 1 times positive 2 is negative 2. Negative 1 times negative 5a is positive 5a. And we have our negative 3 that's left over on the end, and it still all equals the other side, 15 minus 5a. Okay, so now I see that I have a's on both sides of my equal sign. Okay, I have negative 5a over here, positive 5a over here. I like moving the smaller one, which is going to be my negative 5a, so I'm going to do the opposite. Add 5a to both sides. Can only combine it with the a's because that's a like terms, right? So I'm left with 15 equals, well, let's just go ahead and combine these guys because they're both constants. Negative 2 minus 3 is negative 5. And then 5a plus 5a is positive 10a. Alrighty, now I'm looking at my side with my a. Okay, so I need to get rid of what's farthest away, which is going to be this negative 5. So we're going to do the opposite and add 5 to both sides. So I get 15 plus 5 is 20 equals 10a. Okay, last step for getting my a by itself, I have to do the opposite of times by 10, which is divide by 10. So 20 divided by 10 is 2 equals a. And remember, you can write it as 2 equals a equals 2, doesn't matter, same thing. But we figured out that a is equal to 2. Great job. Alrighty, so now we're not solving, we are simplifying each expression. Okay, and how we simplify when we see these parentheses, we just add like terms or combine like terms. Okay, so let's go ahead and write that. We're going to combine like terms. Okay, now here are the rules. You're either going to see an addition sign or a subtraction sign in the middle. Okay, and if you remember, let's write down these rules. When you see an addition sign, the signs stay the same. Signs are the same. But when you see the subtraction sign, the signs change. Okay, and we'll show you what that means in a second. So let's look at number 5. Okay, so this addition in the middle technically is distributing, but because it's addition, these signs after it don't change. Okay, the signs in front are always not affected, and that's a weird way of saying that. They are never affected. Okay, so you can always just write down this first guy. however he looks. So 7x squared plus 4 minus x to the 4th. But now these guys, because it's addition, the signs don't change. Okay, so we have positive 3x squared, so plus 3x squared minus 5 and plus 8x to the 4th. Okay, now we just need to combine like terms. So remember, it has to be the same variable, but also the same power. Okay, so I see 7x squared, I can combine with 3x squared. Okay, so 7x squared plus 3x squared is going to give me 10x squared. Then I see 4, which is just a number. I can combine with negative 5. 4 minus 5 is negative 1. And then I see negative x to the 4th plus 8x to the 4th, because they're both x's to the 4ths. That'd be negative 1 plus 8 is positive 7x to the 4th. And there is our simplified expression, because we cannot combine anymore. None of them are like terms. All right, let's do that again. So in number 6, now this one is a subtraction sign, which means the signs after it are going to change. Okay, remember the first guys always stay the same, so you can always just rewrite them. 3n squared plus 6n cubed plus 7n. Okay, well now they change. This was positive 8n to the 4th. Now it's negative 8n to the 4th. This was positive n cubed. Now it's negative n cubed. And this was negative 4n. Now it's positive 4n. Okay, so now we can combine like terms. So let's see. I have 3n squared, which I actually don't see any other n squared. So that guy can't combine with anything. Now I have n cubed right here. I have another n cubed right there. So 6n cubed minus 1n cubed is positive 5n cubed. Okay, then I have 7n plus 4n, because they're both just n to the first power. That's going to give me positive 11n. And then the only thing I have left is negative 8n to the 4th, which can't combine with anything else because I don't have any other n to the 4ths. So that is our simplified expression. And there we go. We just had to change the signs if needed and then combine like terms. All right. Numbers 7 and 8. It's asking us to solve each inequality and then graph its solution. Okay, so when solving these inequalities, we're going to treat it just like an equation, other than the fact that we're going to graph it after. Okay, so I'm just going to go ahead and rewrite it down here. We have 10 times v minus 9 is less than negative 190. Okay, so now I have room to solve this guy. First thing I see are parentheses, so we need to distribute, which means multiply. 10 times v is 10v. 10 times negative 9 is negative 90. Less than negative 190. Okay, so now I can go ahead and try and solve for v, because that's what we have to graph on our number line. Okay, so looking at my side with my v, got to get rid of what's farthest away, which is negative 90. So we do the opposite, which is plus 90. So I have 10v is less than negative 190 plus 90 is negative 100. Okay, and my last step is do the opposite of times by 10, which is to divide by 10. So I get v is less than negative 100 divided by 10 is negative 10. Okay, and a quick rule, if you were to divide by a negative, the sign would flip. Okay, in fact, let's write that on our paper. Divide by a negative, which means if that positive 10 would have been a negative 10, then we would have had to flip the sign. Divide by a negative, you're going to have to flip the sign. But because we divided by a positive 10, the sign didn't change. So our final inequality is v is less than negative 10. Okay, so now we need to put this on our number line. Okay, so a couple of rules. Remember when graphing, we're either going to graph with an open dot or a closed dot. Okay, when we graph with an open dot, that means it's either less than or greater than. If it's closed, it was less than or equal to, or greater than or equal to. Notice the little line underneath. Okay, because there is no little line underneath, it's an open dot at negative 10. And then we need to decide, well, which way are we going to shade if v is less than, right? My alligator's opening up to my negative 10. Well, the numbers that are less than negative 10, be careful. It looks like 8, negative 8, 6, and 4. But if it's less than, you're shading to the left because all those numbers are getting less than negative 10. And there we go. Okay, let's do that again for number 8. So I'm just going to go ahead and rewrite this guy down here so we have room to solve. Negative 3 is less than negative 10 plus k divided by 8. Okay, so this one kind of looks a little weird. We need to decide on our side with our k which piece we need to get rid of first. It's either going to be the divide by 8 or subtract 10. Okay, well, which one's farthest away from my k? I think these guys are both on top, so they're close to each other. So we need to get rid of divide by 8. So we need to do the opposite, which is to multiply by 8. Okay, so I have 8 times negative 3, which is going to give me negative 24, less than negative 10 plus k. Okay, this is only one more step to get my k by itself. So this is technically saying adding negative 10 or think subtract 10. Okay, well, how do I get rid of subtract 10? We're going to add 10. So I get k is greater than this time because my alligator's opening up to him. Negative 24 plus 10, negative 14. Beautiful. So I have my answer. I have my k's all by itself. So I can go ahead and put this on our number line. Okay, so again, it doesn't have a little line underneath, so I'm going to put an open dot at negative 14. Now, read what it's saying. This is saying k is greater than. My alligator wants to eat the k. So if we're shading, we need to shade greater than, which is to the right. Okay, and let's go ahead and write that. Okay, if it's less than, which it was in number 7, right? V is less than 10. We shaded to the left. If it was greater than, we shaded to the right. Beautiful. All right, next page. For numbers 9 through 12, we are asked to sketch the graph of each line. Okay, so numbers 9 and 10 are both written in slope-intercept form. So let's remind ourselves what slope-intercept form looks like. Okay, slope-intercept form is always y is equal to mx plus b. Okay, you'll see that your y is all by itself on one side. Okay, so now we need to identify, remember within this, our m, or whatever's in front of our x, is our slope. And the number on the end is our y-intercept. Okay, we really like slope-intercept form because it's really easy to graph these guys. Okay, so let's look at number 9. Okay, so in order to graph this guy, we need to identify our slope and our y-intercept. Okay, so my slope is in front of my x, so it's going to be negative 3 over 2. My y-intercept's on the end, so I'll underline that. Y-intercept's on the end, positive 5. And that's awesome, but what do we start with? Okay, do we start with our slope or rise over run? Remember our slope. In fact, let's make that reminder. Slope is always rise over run. Or do we start with our y-intercept? Okay, remember that we always start with our y-intercept. That's an actual point on our y-axis. Okay, so find positive 5 on your y-axis. It's this guy. And put a point there. Positive 5. There we go. Okay, so now I'm going to use my slope, rise over run, to count to my next point. This is negative 3 over 2. So it wants us to go down 3. 1, 2, 3. And over 2. 1, 2. Okay, you only need 2 points to connect these guys with a straight line, minus straight-ish. Okay, but let's make a note on our paper. Okay, our slope was negative. Okay, so remember that negative slopes go down to the right, which this guy is, right? This line is going down to the right. Okay, that's a good way to check and see if you graphed it correctly. Okay, number 10, still in slope-intercept form. So let's go ahead and identify our slope and our y-intercept for this guy. My slope is right in front of my x, so that's going to be 2 over 3. My y-intercept is at the end, so positive 2. Okay, remember we start with our y-intercept. Okay, so find positive 2 on your y-axis, put a point. Then we're going to use our rise over run to count to our next point. So rise 2, run 3. So up 1, 2, run 1, 2, 3. And connect those 2 points, arrows at the end. Okay, so our slope this time was positive, right? Positive 2 over 3. So it goes up and to the right. Beautiful. Alrighty. Numbers 11 and 12 are not written in slope-intercept form. These guys are actually written in what's called standard form. Okay, meaning your x and your y are on one side of your equal sign. They're on the same side. Okay, so what we want to do is we actually want to we want to rewrite this so y is all by itself so we can graph it just like we did on numbers 9 and 10. Okay, so I'm going to go ahead and rewrite this guy. So I have x minus y equals negative 2. So I want my y to be by itself. So the farthest thing I need to get rid of is this x first. Do the opposite by subtracting x. So now I have negative y equals, remember when I said that x likes to just bump his way in front? Negative x minus 2. Okay, and my last step, because my y is not all by itself, is do the opposite of times by negative 1, which is to divide by negative 1 to everything on that side. So now I have y is equal to negative x divided by negative 1, positive x. Negative 2 divided by negative 1, positive 2. Notice now he's in slope-intercept form. Okay, so I can easily identify my slope and my y-intercept now. Slope is in front of my x, which is going to be that invisible 1. Y-intercept's on the end, which is positive 2. Okay, we can go ahead and graph this guy. Start with your y-intercept. So find positive 2 on your y-axis. And then our slope is 1, or if you like to write it as a fraction, 1 over 1. Up 1 over 1. And connect those 2 points. Goes on forever. And there we go. Okay, so let's do that again for number 12. So again, this guy is not in slope-intercept form, so I need to rearrange him so he is in slope-intercept form. So I'm going to rewrite him over here. X plus 5y equals negative 20. Okay, and I need to get my y by itself. So Looking at my side with my y, the first thing I got to get rid of is this x. So we do the opposite of positive x, which is negative x. So I have 5y is equal to negative x, pushed his way in front, minus 20. Okay, and I still need to get y all by itself, so we do the opposite, excuse me, of times by 5. Divide by 5 to everything on that side. So I get y is equal to, ooh, this guy's kind of weird. This turns into negative 1/5, or 1 over 5, x. Negative 20 divided by positive 5 is negative 4. Okay, so again, now he's written in slope-intercept form, which we can easily identify our slope and our y-intercept. Slope is in front of my x, so negative 1 over 5. Y-intercept's on the end, negative 4. Okay, start with your y-intercept. Find negative 4 on your y-axis. It's right there. Now I have a slope of negative 1/5, so we need to make sure it goes down and to the right. So down 1 over 1, 2, 3, 4, 5. And there is our line. Great job. Okay, last thing we are going to talk about on this review is simplifying radicals. Okay, so when we're simplifying radicals, remember that we're trying to get pairs to leave the radical. Okay, so let's remind ourselves, trying to get pairs to leave the radical. Think of it, like I said in class, they have to pair up in order to leave the house, go on a date. Okay, so we're going to go ahead and ignore the 8 in front. Just think of that as like a couple who's already outside waiting for their friends. So the first thing I want to simplify or break down is this 192. Okay, well, what can I divide 192 by? I'm just going to experiment with some things. I know it's even, but I kind of want to break it down a little faster. So maybe can we divide it by 4? Yep, we can. So we can divide it by 4. This gave me 48. Don't see any pairs yet, but I know I can divide 48 by 4. Okay, that gives me a 4 and a 12. Okay, and I already see a pair that gets to leave, a 4 and a 4, but that doesn't mean we're done. There could be some other pairs that get to leave as well. So I'm going to keep breaking down. So 12 can break down to 4 and 3. And 4 can break down to 2 and 2. 3 can't be broken down anymore. So I got 2 couples that got to leave out of 192. So I have a 4 that got to leave multiplied by the 2 that got to leave. Remember, they create 1 couple. Okay, I'm going to leave a little space in case anything else gets to leave later. But the one number that had to stay in that couldn't pair up is that 3. Okay. So we took care of the 192. Now we need to take care of the n to the 5th power. Okay, there's a couple ways you can do this. You can draw out 5 n's, 4 or 5, and see how many can couple up. So I can create 2 couples with 1 left inside. Or what you could have done, especially if it's a big odd number, you can take 5, because it's odd, subtract 1. Okay, that's going to give me 4. Okay, well, how many pairs can I get out of 4? 2. Okay, again, I got 2 couples of n's that got to leave and the 1 that had to stay inside. Okay, so that's a little trick that you can use. But again, you're more than welcome to draw them out. So I see that 2 couples of n's got to leave, so n squared out front, and then 1 n inside. Okay, we can simplify, but we cannot forget the 8 that was outside waiting. Okay, so now what we do is we just multiply everything in front. So I have 8 times 4 times 2, which gives me 64 n squared, got to leave, 3 n had to stay inside, So we are simplified. Beautiful. Alrighty. And I totally did not mean for this to happen, but we have 192 again. Okay, so I'll just draw it out again. We did 4 times 48, 4 times 12, 4 times 3, 2 and 2. That is so funny. I totally didn't even notice that. Okay, so I have a couple of 4s, a couple of 2s that got to leave. So I have one couple of 4, one couple of 2, and again, my 3 that had to stay inside. Okay, easy peasy. We took care of the 192 twice, technically. Now I got to take care of my variables. So I have m squared, or m times m. Okay, well, I have 2 of them. I have an even number. So how many pairs can I get out of 2? Or 2 divided by 2? I get 1. Okay, now we are going to have to multiply to simplify, but we cannot forget the negative 4 that was waiting out front. Okay, so now we have negative 4 times 2. Negative 4 times 2. So I get negative 32 with my m. And root 3 was the only thing that had to stay inside. And there we go. That is simplified. All right, last 2 examples. Okay, we have to simplify in order to add these guys up. So these guys act just like terms, okay? So we're basically combining like terms here. But in order to get like terms, they have to be the same number inside the radical. So right now I see a root 45, root 24, and root 6. I can't combine any of those guys. So I need to see if I can simplify any of them in order to combine. So I'm going to look at just the first guy. Okay, and again, negative 3, he's just a guy waiting outside, seeing if any friends can come out. So I'm just worrying about 45. Okay, so 45, I know, can be divided by 5, and that gives me a 9. 9 I really like, because that gives me 3 and a 3. So I have a couple of 3s that gets to come out and multiply by who was already outside, was the negative 3. So this whole first piece, negative 3 root 45, turns into 3 times negative 3, negative 9 root 5. So that was the guy who had to stay inside. Okay, let's see if we can simplify 24. Okay, so 24, I can simplify to, let's see, 4 and 6. 4 can be broken down to 2 and 2. 6 can be broken down to 2 and 3. Okay, but only one couple of those 2's can come out and multiply by the 3 that was in front. Okay, 2 and 3, they can't come out, so guess what? They just turn back into that 6. Okay, so now I have 2 times 3, positive 6, root 6. I had to stay inside. Okay, well, we just saw that 6 can't be broken down to find a pair, so this guy cannot be simplified. So he just stays plus 3 root 6. Okay, now can I combine any like terms? Do I have any like terms? Yes, I have root 6 and root 6. So I just think, okay, what is 6 plus 3? That's going to give me 9 root 6. And then I had my negative 9 root 5. And it's being added to 9 root 6. And that is fully simplified. Okay, because root 5, root 6, I cannot combine. They are not like terms. Okay, let's go ahead and do that again. Last example, number 16. Okay, I have a root 24 and a root 24. Let's see. Can I combine those right off the bat? Yes, I can, but I'm probably going to have to simplify it to see if it breaks down anymore. But let's go ahead and just let's combine these guys. Root 24 and root 24. So what is negative 3 root 24 minus 3 more root 24s? That's going to turn into negative 6 root 24. Okay, and then I'm just going to write what I have left over, negative 2 root 6. Okay, now again, this might not be your final answer because we can break 24 down. Okay, so let's go ahead and break 24 down, and that's so funny. We already kind of did it over here again. Did not mean to do that, so we can do 4 times 6, 2 times 2. And we already figured out that we can't break 6 down anymore. So I have one couple of 2's that gets to multiply by what's out in front. So this becomes, I'll write it over here, 2 times negative 6 is negative 12 root 6, that had to stay inside, and minus 2 root 6. Are these guys like terms? Can I combine them? Yes, I can. They're both root 6 and root 6. So I just say, what is negative 12 minus 2 more? It's going to give me negative 14 root 6. Okay, so you can combine these right off the bat and then simplify. You could have simplified them, then combined them. You still should have gotten the same answer, but those are your notes for today, and you have an assignment that goes with it.